All right, welcome back. This is Microsoft Virtual Academy, and we are getting started with Template 10. We're now talking about some of the converters. No, we're talking about all of the converters that come with Template 10 that you'll be able to use inside your application. Darren, walk me through just the purpose of a converter. When would be the time I start turning to a converter?
You'd be turning to a converter if you're using data binding and you have a data source in your view model that is perhaps a data type that relates to your business, as opposed to something that you would render up in your UI. So, for example, if you want to control the visibility of a control that's on your UI, but you want to tie it to a Boolean value that says whether a business rule is enforced or not, you can't bind a Boolean value to is enabled, or is visible, rather. You have to convert that value from true to visible, or false to collapsed, or, in fact, the reverse sometimes in certain business rules.
So in fact, that Boolean to visibility shipped with the early templates in Windows 8.
Yeah.
Yeah.
Yep.
Right.
And so, fundamentally, it's a data binding construct that allows you to express in your data binding syntax in your view model that you're going to use a certain class to help convert those values.
All right, so let's talk about what we give you. And so here's one thing that's important is Boolean divisibility is a great example of one that every developer is probably going to be writing. Or the reverse Boolean divisibility would be another one. It would be awfully nice if instead we could write a type of converter that isn't bound to something specifically and you could reuse. And so that's where we introduced the value when converter. And the value when converter is basically saying, we know you need a Boolean to visibility converter, but we also know you need other kinds of converters as well. And instead of writing dozens and dozens of converters, let's write just one. Let's have one, and let's allow you to declare what its operation is inside your XAML. All right, so let's look at the properties of it, because I think that is pretty handy. There are three properties to the value when converter. The first is the when, and so this is when whatever it is you're binding to is this value. So in your example, it was Boolean, right? So when true, for example, then I'm going to pass back the value. And so that's the second parameter or property, value. And so in this case, I would say when true, then the value is visibility, or visibility, visible. Otherwise, when it's not true, then it's going to be collapsed.
And so there's some really clever things that are going on here because we're using some of the type inference that's available in XAML to actually understand that true is a Boolean value and visible comes from visibility.
Yeah, that's exactly right. In fact, it might be even more clear if I give you a quick demo. So let me pull up Visual Studio. I've got it laid out here. All right, so I am in, this is minimal. I have minimal here right now. I'm in the app XAML, so I can create a global converter that I'm going to use inside my application. You could obviously put this in page resources as well, but I'll put this in application resources. So if I say converters, which is something I've predefined up top, right? It points to template 10 converters.
Just a nice
I can see all of them that I have here, and we'll start with value when, because that's what we're showing off now. And so I'll give it a key, and this will be, we were just talking about Boolean to visibility, so I'll call this the Boolean to visibility converter, just like so. And in this case, I now need to define the three properties in order to use it properly. So I'll use the full syntax so we can show how we can use typing and get autocomplete. So first I'll say the when value, so when it's something. So in this case, I'm going to say x Boolean. So when it's true, right?
Said x bind. Auto-compete.
Boolean. There you go.
It's not auto-complete, it's auto-compete.
It's competing with me.
Exactly.
Good. All right, so now when it's true, I'm going to set what its value is. So I want the value now to be one of the visibilities. In this case, I want it to be visible, just like so. And if I misspelled it, then I would get a compile error, which is pretty nifty. All right, so then I will say what its otherwise is as well. And I'll say it's visibility collapsed. C-O-L-A-P-S-E-D, collapsed. Two L's in collapsed.
Still.
What's that?
It's still.
It's still spelled that way.
Yeah.
That's right. It's spelled that way for a while. I mean, until they deprecate it.
Yeah.
the word collapse.
L-M-A-O.
All right. So now this is the same as if I had gone in, created a converter class, created a Boolean to divisibility converter, implemented iValue converter, and done all the work internally. So I don't have to do that. I don't have to start polluting my my project with a whole bunch of converters that really just need a quick little declaration and they're done. In fact, I could take this exact one. I'll just duplicate it, and I'll say Boolean reverse Boolean divisibility. And in this case, I'll say false. Done.
Yeah.
Right now, everything is the opposite of before. So it's pretty handy. And if I were to implement this, I'll implement the Boolean divisibility converter. I could go into my main page, right, and say, I'll just do it right here in XAML. I can go down to my resizer as an example, and I could say visibility. Let me bring it down to a new line, and I'll do the binding here. I'll bind it to my view model is admin or whatever, right? I'm just making this up.
Yep.
And I would do xbind in this case. Okay. Xbind view model is admin with a converter, a static resource, and we'd already named it the Boolean divisibility converter or wherever it is we would create. What's nice is I pass in a true, but I could also pass in a custom enum or any other value that's appropriate for us. So there are other things as well. I can handle null and other situations as well. So it's really, really nice.
Yeah, and converters can also work in not only one way, but also two-way. So coming from your view model, it will convert the Boolean to a visibility. And then if you specify that your binding is a two-way, then when it comes back from the control back into your view model, it'll convert from a visibility back to the Boolean value.
Really? Is that the way it works? Wow. Again, you forget about all these things.
Yeah.
All right, that's terrific.
That's the two methods in a converter.
Okay, so that is the value when converter. So there's a couple of more we want to talk about. Let's drop back to slides so we can really talk about them in depth here.
Absolutely. So you just demonstrated the value when converter. And so we've got an example in here as well. Now let's talk about the change type converter.
Come on, Barry. There you go.
There he goes. Wakey, wakey over there. So the change type converter, apparently he says there's only one. I'm not sure what that means. The change type converter.
He's saying you're number one.
Oh, that's right. That's what it is.
He's pointing at a ceiling tile.
I know. It's so strange.
Really,
It's a strange
elbow looks like
strange man.
Itching his elbow.
So change type converter. So this came about really because of xbind.
Yeah.
So xbind exists because there was certainly the perception that classic binding has a lot of performance issues.
That's right.
Because it's reflection based. Xbind is, at its foundation, a code generation framework that allows you to generate code at compile time. That means there isn't that runtime overhead of doing reflection and casting and so on and so forth to bind your values in your view model to your UI.
Right, and it has a requirement that what you're binding to, property value type, matches what you're binding from property value type as well. It has to be the same type. For example, your example in this is actually perfect because selected item is actually object.
Yes.
And object is great. If you have a user class, that will cast down to object just fine.
Yes.
But object doesn't cast up to a user class.
And one of the...
Well, it does, but it's not reliably doing it.
Well, and that's one of these things is xbind requires it to be explicitly of the type. So although you could argue that everything is an object, which in reality it is,
yes,
the reality is you can't assume you can cast an object to every type. And so you have to be explicit. And
so you don't get this error in classic binding.
You don't.
You only get this error in xbind.
And that's because classic typing is using reflection, and it uses what's called duck typing.
Yeah.
Which, if it walks like a duck, quacks like a duck, it's a duck.
Basically, everything behind the scenes is always object.
Yes.
So there's no up and down casting.
Yep. So that works great in that scenario when you want ultimate flexibility, but if you want performance, then you want the most specific case possible. That runs into the problem that you then need to leverage a converter to marshal your strongly typed view model object to an object, and vice versa. When you make a selection in a list view, it sets the selected item, which is an object, and you need to take that object and cast it back to the strongly typed value so you can assign it in your view model.
Hopefully that you could recognize that this is sort of a nightmare scenario, and it really makes it so that xbind is...
It's worse than that, Jerry. It's worse than
that. You wish it was a nightmare.
Yeah.
But what's great is this makes it so that xbind is really unusable in certain situations. But when you use it in conjunction with this converter, it kind of enables xbind to once again be used. And so actually, let's look at the syntax one more time. So in your list view, you're saying selected item, xbind to the current item. Mode is two-way. That's because we want to write back and forwards from the object to the object. And then you say converter, type converter, the end. You don't have to say what type you're converting from. You don't have to say what type you're converting to. The binding subsystem already knows all of that and actually passes it as a parameter to the converter for us automatically.
Yes.
We then can just read that target type and do all the conversion behind the scenes for you. Everything works like a charm, and you're done. That is how easy the implementation is. It's not a bunch of extra who knows what. You just need type converter in there, and if you didn't have this, your only fallback is to use binding. Or you could change your view model property type to object.
Yes. And then you could have a strongly typed property that you use in your business logic inside your view. Yeah.
Unstrongly typed.
Well, you'd have that, and then you'd have a cast inside.
Every time you cast it. Yeah, that's right.
Yeah, you'd say real business object.
Yeah, that's right. So as we move forward in Windows, and we see Windows XAML progressing, and we also see xbind progressing, we might actually find this converter is no longer necessary. Today it is, and it enables us to use xbind in scenarios that would otherwise preclude us from using it. So why do we have type converter? It is there for xbind, and it enables those scenarios where it can't cast, basically can't cast up to a type from object, especially in things like selected item. It's very limited use, actually. You don't have that many properties where xbind has this problem.
I mean, if you're binding to a text block's text, string works great.
Yeah. All right, so that's the change type, but there's another converter, I think, that is another very common one, and that is the string format converter. And so actually, it's not common. String format is not a common converter at all. Instead, people create a very explicit one. So, for example, a conversion might be from date time to day of week, right? And so you pass in date time, but all you really wanted was Wednesday.
Well, what a lot of people are doing in reality is they're actually creating read-only properties in their view model that does that formatting for you.
Yeah.
So you might have a date time value that's part of your model. And then on your view model, you might have date time as day of week, date time as month. And those would be already doing the conversions to strings, and then you would have all of these different properties that you're binding. What this converter does is allow you to get rid of all that additional plumbing and just do the formatting where you're actually leveraging it in your UI.
That's right. It's worth pointing out there's two things worth pointing out. Darren just brought up a scenario where instead of using a converter that extracts the Wednesday for you, the day of the week for you, you could have a property in your view model that does it as well. That is, from a performance point of view, that's the best possible option. Right? That is terrific. There's a lot of work for you to make sure that iNotify property change is being raised for all the correct properties. That's not too difficult. We're all developers here. We're all pretty smart. We know what we're doing. That being said, if it's not in a repeater, right, if it's just one or two fields here and there, it actually makes plenty of sense to use a reusable converter that you can declare. And so just like value when converter enabled you to have the Boolean divisibility converter just by declaring it in your XAML, so does the string format converter. Allows you to have date time to weekday and many other things, right? All the things that you kind of want to have pulled out there, you can do in a really clean, declarative way inside your XAML. So why does string format exist? Because we know that date to month, date to time, date to date only are all things that we're going to create anyway. Maybe it's not date, right? Maybe what you want to do instead is format a double to a currency and take away the decimals or add the decimals or whatever that. We create converters for those as well. The reason we have string format is so that we
let's have a look at my screen, and we've got some examples of these things where we actually have declared a standard string format converter, and then we've got a price converter and a value converter where we're doing precisely that, where we've got a numeric that's going to 4 decimal places and another that's going to 2 decimal places.
Yeah.
So we've actually pre-canned the format that we're going to leverage there. And then as you can see down in the text blocks examples there, where we've got the first one, because we haven't determined the format as part of the string format converter definition, we can actually add a converter parameter that specifies it in line in that binding. But on the remaining two, because we've already pre-declared those during the resource declaration, we actually just use those as is, and it will automatically.
I see. So you have one of two options. You could either set the format property when you declare the actual converter, or you could pass in a converter parameter with that actual format.
Yeah, and there's values to both. Obviously, the first one gives you ultimate flexibility wherever you're using it. But the price converter and value converter allow you to centralize a common way that you're formatting data. So if you wish to change that, say for whatever reason, suddenly your values need to be expressed with 3 decimal places. You change it in one place and it's reflected throughout your application. So that's a lot of the benefits of that centralized resources and using those things.
I love it. I love this converter because it allows you not to start filling up your project full of classes of little converters that do small things. Then you stop using them and you don't delete them, and then all of a sudden you've polluted your entire project with things that you've got to test anyway. So this is really great. Now, the format string is a little bit tricky on this.
And I challenge anyone to remember every single variation.
Now, I have beaten that challenge, but I don't want to do it now.
You don't want to embarrass us all.
Right.
So, fortunately, what we've done on this slide is we've collected together links that will go straight to all the various types of formatting. So you've got formatting for objects, and then you can dive into all the date time, format strings, numerics, and so on and so forth. So this is also in the wiki for template 10, the same link. So you can
That's right. If you're looking, how in the world am I going to download this slide? Because I have to get that one slide.
Yeah.
Just go to template 10. Just go to aka.ms/template10. That's the quick way to get to the GitHub repository. You can also go to GitHub and search for template 10.
Yep. And you'll find them all there.
You'll find several repositories that have cloned and copied template 10, and then you'll have to find the original. That's right. 3 converters that come with template 10. The first one is the value when converter. The value when converter is your ability to create this conversion of one property to another property value. The second one, what's the second one? Forgot the second one.
Value when change type.
Change type. Change type. Because we're using Xbind and trying to use Xbind more and more in our application for the sake of performance, sometimes we need to change the type because it's both must match. That's the way Xbind works. And then the final one is string format. String format allows us to provide that native kind of .2 string, .NET format string to our values as they come in, either date time or any primary primitive, primitive type can do that, and allows you to not have to create all those converters, but to just declare them either at the page scope or the application scope, whichever is correct for you. Why do these exist? Because we just wrote them over and over again. They belong in a reusable library. That's why they're in template 10.
But wait, there's more. Show my screen.
Oh my gosh, what is it? Oh, the real world?
The real world. The reality is, every time you use a converter, you're introducing overhead to your system.
That's right.
So, as Jerry mentioned previously, having pre-calculated properties that are on your view model is probably the most optimal way to introduce a lot of these conversions. However, those overheads really get compounded when you're using things inside of repeaters. You mentioned things like the items control, list views, and so on, where you have a data template, and in that data template, you have one or more converters on each one of the binding expressions. That overhead is being...
If you've only got one item in your repeater, that's not a big deal.
Yeah, that's not a big deal. But
if you've got 10,000...
Yes, it's pretty substantial, because every time it's generating an instance of that template, it's going to run through those converters.
That's right.
Every time you update your view model, it's going to run through those converters. And so you need to think about the particular scenarios in which you're using these things and make sure that you're optimizing for the real world in which you're working. Sometimes convenience isn't the best way.
If you're looking just for a rule of thumb, if you're outside of a repeater, you're probably all right. If you're inside a repeater, you're probably not. That's pretty good.
Sounds good.
All right, we have 3 converters inside template 10. They're all for you to be able to declare them, so you don't have to have a whole bunch in your project. Hopefully you like them, you love them. Good luck.